Video is going to focus on another of the most kind of valuable and commonly used tools in the Raster toolkit, and that's kernel density. This is a tool that has some analytical purposes, but is very commonly used visually to create concentrations of intensity and to show where the occurrences of a certain thing are happening most densely versus most sparsely. And the mechanics of this tool, as we outline in the video on the desktop channel, are fairly layered, take a minute to really sort of master. But once you do, you can use this tool for a variety of different things and at a variety of different geographies. You can use it really to show very granular concentrations, like try to see which intersections are the most dense for something happening. But you can also do it for far less granular things, right? Try to see density over like a neighborhood or over a multi city point of view. So I'm going to kind of walk you through each here. What we're doing is we're creating what's called a heat map. Now we're going to actually create an individual raster layer that we will get to analyze with this information, but to visually remind you of what you're doing. Right here I have a point layer, and the neat thing about Pro is I can actually on the fly visualize what I'm trying to do by coming to symbology and go to heat map. And a heat map's purpose is to show intensity of a thing, right? So this is the area where the greatest concentration overall of crashes happened. You can see up Broad Street in Philadelphia, Roosevelt Boulevard, 95, right? These main roads tend to have kind of a high volume of crashes, and there are certain points that are more intense than others. This tool, though, is pretty interesting because the truth you're going to tell, right? Because I don't mean to at all take a ridiculous sort of fake news, my truth is better than your truth point of view, but I legitimately mean that, like, when we're looking at points about crashes, this intersection here is extremely dangerous. A lot of crashes, or one really bad crash, have occurred here, right? But that also means if you look at a larger radius, right, it's only really that point that's sort of influencing it, versus down here, maybe there wasn't one section that was particularly bad, maybe this street, but it's super red because a ton of crashes are happening all in this area. And I'm bringing that up because if I wanted to actually show maybe a truth that was like, really show me the intersections that are the worst, look how I'm decreasing my radius. And notice what happens is the extremely red points become smaller and more concentrated. So I can actually see, okay, that's an intersection at a high density of crashes. That's an intersection at a high density, high density, high density. All these other areas had crashes to a degree. We never want to undersell them, but I can really see what kind of pops out here. Versus I could even increase the radius more to something like 40, and I'm going to lose that granularity. Instead, I'm going to show broader neighborhood trends of density, right? It becomes fuzzier, right? It becomes less sharp. The story I'm able to tell here is that generally this part of Philadelphia, right, in downtown and West Philly, are unsafe. Generally this section of Broad Street and up here on Roosevelt, but I lose that ability to sort of see at the intersection level now. So we're going to learn how to actually do that with a tool so that what comes back to us is not, a visualization that says dense or sparse, but something that maybe tells us what the estimated, number of crashes per square mile are for any given pixel. So I'll turn it back to the regular symbology for a moment, just so it's sort of easier, to visualize what I want to do here. I'll click on my point. I'll go to the properties, bring you down to like a 3 or something. A lot of points here. Apply. Maybe make you a nice dark black so it's easy to see. Challenge always with Pro. Sometimes due to the online connectivity, it can generate a little slower than you want it to. All right, so I got my crash points. This tool is also an analysis. It's going to be one of the top 15, right, or top 20. You know, there are certain tools that as you become more familiar with Pro are here because they have a lot of value and are used a lot. And this one's actually on the second page, right? It's right here, Kernel Density, excellent tool, very commonly used. So you can just access it from here. If you're trying to build your muscle memory, tools, toolboxes, spatial analyst, density, kernel density. So open it up. Notice this will only work on a point or a line. So for this one, we'll drag in crash data. So this is a really critical field. You know, it's one of those that sometimes maybe in our rush to just see the result of a tool, we might rush through when actually you want to engage it. Here's what it means. Remember that a point has no geometry. A point is literally there to reference an instance of a thing, a location of a crime, a location of a crash. But depending on how the data is actually coded, that single point might mean one instance or it might mean multiple. Let me give you an example. We're not going to do crimes, but I'm going to open the crime attribute table and just sort of familiarize myself with what's there. So I'll open it. Each one is a crime, and it tells me when it happened, the day, the time, the general area, and then if I keep kind of going over, I can see what occurred, and then a recording of the XY coordinate. So in that instance, there's no field that is saying 2 crimes happened here, or 3, or 4, or 5, or 6. This is an example of a point where each point is the only incidence of a thing. It may be that like 15 points overlap each other in the same area, but that data is not recorded in the table. This is different than crash data. If I open crash data and I scroll over, what I will eventually see is that there are fields telling me the number of instances of motorcycles being involved. How many buses were involved in this incident? How many small trucks? How many bicycles? So there's a field here that's actually indicating the number of vehicles, right, or the number of automobiles or whatever that were involved in an incident. And so what I'll do then here maybe what I actually want to see is not the density of crash instances, but how many different cars were involved. And that's a very different thing, right? Because this is one point here, and it won't show on my map, unfortunately, because it might be hidden somewhere else. Wherever this point happens to be, only maybe one location, but there could have been like 10 different crashes involving 22 vehicles over time, or one crash involving 22 different vehicles. Data can be coded this way. Sometimes there is a value in the point data that tells you the number of times something occurred here, the number of people here, the number of restaurants on this spot. You just need to be aware of your data enough to know what to put. And so that's what I'm going to do. I'm going to bring in vehicle count. So I'm not just looking at the incidences of the points, but I'm looking at the number of vehicles. Now I'm going to create 2 of these. The first one I'm going to do, I'll make it a smaller one. So I'm going to call you Dens, let's say 400 or 500. Make my cell size 25 feet. And here's the other very critical point. Here when you come to a search radius, this is kind of what we were controlling in the visualization scheme a second ago. What this means is how far out do you want me to spread the influence of every point? So if I were to do 500, right, 500 feet, it means that every point is only going to go out at a distance of 500 feet. And what that will effectively do is this is only going to show you the really granular incidences of concentrations. Right? To show areas that are really, really darkly colored and are dense, What would have to be true is that a lot of incidences occurred in a very small area. And actually, just to make it a little bit better, I'm going to change it to byte count here because that one vehicle count's going to overwhelm everything. 500 feet, meaning only areas that are going to be really dense compared to others will have like 3, 4, 5, 6, 7, 8, 9, 10 crashes with bikes happening really close to each other around an intersection. In a moment, I'm going to do another one that's 2,500, and you'll see how that's different. For these, the big controllers here, either the cell is going to come back telling you what the estimated X per square mile is, or X per acre, right? It's just giving you like a feeling of density. The more complicated way to do it is actually the expected counts, right? If there were 100 points, it'll actually divide how many it would expect to find in that cell based on the intensity. So you might see like 0.0001 point versus 0.0002 points. You'll learn whichever one of those is more comfortable for you. I tend to do the density, square miles. So I'll run it. Bleegity blabbity bloop. It's going to do its thing here. And, it's going to show us an example of what I would say ArcGIS not always picking the best symbology at first. So when it comes back, I'm going to shift the symbology to be something that's a little bit better for my ultimate purposes. So give it a moment to load here. Very good. Right, I have it here. Maybe it doesn't look like anything's happening at first because of the way they've chosen to do the symbology, but let me turn off the crash points and see that it actually is working. It's just there's a spot that is so dense here, right, that it's purple and everything else isn't. So maybe I'll go to appearance and I'll change the symbology to a stretched, and I'll stretch based on like a red color. So I'll do like a light red, and I'll stretch a percent clip is totally fine. And then maybe I'll come up here to my transparency and I'll make this more transparent. And that becomes something a little bit more usable. Now I can start to see like the really intense areas where it's heavily, heavily concentrated versus those areas where it's like just a light pink and it's a little bit lighter. Compare that to as if I run the same exact tool, but this time I'm going to make the search radius, the distance that I'm spreading out my influence a little bit larger, right? So I'll choose crash data true here. Population field is still going to be bicycle count, so I don't create a totally different result. I will come and choose, D 2500, 2500 foot density here, or den 2500. Just keep my cell size 25, so we're lined up. But I'll make the search radius 2500. So what's going to happen here is that everything's going to spread their points out farther, so the amount of total influence is going to be weaker, but what it will allow is this kind of variation of color over a larger area. So you can't really show dense intersections here. What you're showing is like dense neighborhoods, areas where like overall over like a larger distance there's a high concentration within that broader area. So we'll run it, let it do its thing, show its output, and then I'll give you one last sort of analytical tip that I find is useful when working with density to make them easier to visualize so you don't always have so much noise clouding everything. We'll talk about that in just a second. So, I mean, if we're being very honest, I could probably just edit these videos so we didn't have to sit through this every time. But, yeah, I'm a little bit lazy when it comes to that, so hopefully you all won't mind too much my little monologue right here about how long this is taking. Oh, excuse me, buddy. There go. It's going to take it a second. All right, you can sort of already visually see it's going to be very different, like it's showing the trends larger. Let's change to a stretch that is red again. We'll do a % clip. And then we are going to take care of some symbology so that it's a little transparent. Beautiful. All right, so 2 different applications of the tool. Both stories are 100% true. I've searched everybody's point out over a 2,500 foot area. And so all that's saying is that in this area, like generally right here, there are a ton of different points with kind of high values in the bicycle count field within a broader 2,500 foot area. So the conclusion you'd be drawing here is generally this part of Center City can be a little bit dangerous to bike in. This part of West Philly can be a little bit dangerous to bike in. It can be a little dangerous to come up here around Girard, you know, but then the other areas, it's sort of less so and less so. Contrasted with this, where I made a very, very small search radius, what this is showing is really bad intersections. And that's like a great example right there, right? If I click that point actually had, maybe it's not that point. That one only had 1, but let me select it and see if I can get the answer there. If I come to my selection, and I select this kind of point that's got a ton of red around it, and then I open my attribute table to look, as I'm hoping you can see really quick and it'll show, the reason this has become so intense is, it seems to have frozen, but there are 27, right? 27 different points that were selected in that one little area there. 27, meaning that this is a really, really sort of dense intersection right around there. 27 kind of based on that point. And that's why it's super red. So that's the story you're telling here. You're not showing density over a neighborhood. You're showing it at an intersection level. There's no necessary like perfect mode here. You need to learn as you go what trends you want to show, right? You know, again, I recommend if you really want smaller trends, search radius of between 300 and 500 feet is usually good. If you want broader trends, usually between 1,500 and 3,000. So last thing I want to show, one thing that has always frustrated me about density as a tool, and I'm going to come back to the appearance quick here. Like if I take my symbology off here, right, there's a whole bunch of noise that's screwing things up. And it doesn't maybe seem like it's that much of a problem because we just, we did a nice symbology there and it turned it to be, why is it so big? Right, and it doesn't seem like it would be that terrible. We had a bunch of noise, but, ultimately we were able to hopefully factor that noise out, or so we think by turning the swipe up and not seeing it. But analytically, we still have a problem. And that problem is there are millions and millions and millions and millions of pixels that have a value of 0, meaning there's no density. And that's fine, but the problem is a lot of that garbage is here. Right, a lot of it has been spread out into the world. It's not actually overlapping Philadelphia, so it's just creating all this unnecessary noise. So there's a couple ways I could fix this, right? I could do what's called an extract or a clip raster, which will be a later video. But there's also a technique I like which just removes any value that's 0 altogether, even if it's in Philly, so that what we're only looking at is areas where there happens to be some density. And I set it up using a kind of a Raster Calculator expression. So if I come into my tools and I go to Map Algebra or Spatial Analyst, Map Algebra, and I pick Raster Calculator, I'm going to set something up that says density of 500 times con, in the instance of, right, conditional, density of 500 is greater than 0, comma 1. What a conditional does is it creates a temporary new raster. Conditional setup like this. In the condition where density of 500 has a value of greater than 0, comma, return a 1. if I don't put another comma after here, right, I could put a comma and say -1 or, 0. But if I don't put a comma for the false value defaults to no data. So essentially I'm creating a grid where if the value was greater than 0 for density, it has 1, and if it wasn't, it was a no data. And then I'm multiplying that by the original, because 1 times any value is itself, and no data times any value is no data. So it would effectively just eat away all of the noise. And that's what will end up happening here, is I will create a new, better analytical grid that gets rid of my 0 values, or gets rid of the values that I don't want. So for future steps, if I'm calculating averages or running statistics on my raster values, I don't have that garbage noise. I've only got the areas that have an actual density, and it's a little bit easier to see with kind of out that noise filtered through. So that's kernel density. The analytics are roughly identical, but I want to get you comfortable with the mechanics in Pro.